Okay, so yeah, let me continue about data writers.
Just a second. Just a second. Do you want to start from the beginning, meaning say today and what's the event announcement?
Okay, repeat. Sorry, everyone. You have to bear with me. Okay, hello, everyone. I am Jayarada Natarajan. I'm the organizer of the Big Data Riders Meetup group. And so today we are going to discuss about Druid plus Trino Fang analytics without Fang engineering cost. And I will introduce the speaker at the after the these slides. Okay, and I am the organizer, Jayarada Natarajan, and Arivoli is the co-organizer of this meetup group. And we are in Bay Area for the past 5+ years, and we have done 52 events so far. And we have 4,700 members, 4,700 plus members in our meetup group, and 57 speakers spoke in our group. And we have done meetups with Fortune 500 companies like Google, Facebook, Oracle, Uber, a lot of companies, and also startups focusing on open source. So our main focus, even if it is Fortune 500 companies, the focus will be only on open source tools and technologies, right? And we have done tech talks, hands-on workshops, and hackathons. We had a lot of sponsors they have provided space, food, etc. during our meetups. These are some of our sponsors, and and this is our website. And for more details, please browse this website. And our speakers are okay today. Druid plus Trino, Fang analytics without Fang engineering cost is the topic we are going to discuss. And our speakers are Rachel Pedeschi. Hope I spelled the name correct, or bear with me. VP of Community and Developer Relation at Imply. Rachel is a VP of Community at Imply. Data geek. Rachel is no stranger to the world of high-performance database and data warehouses. She is a Vertica Informatics and Red Brick certified DBA on top of her work with Cassandra, and has 20+ years of the experience in business intelligence and ETL tools. And Brian is a Trino developer advocate, and he's a US Marine turned software engineer and developer advocate working to foster the open source Trino community. Brian spent 4 years as a data engineer at cybersecurity company working on pipeline maintenance and query optimization. While in this role, Brian was responsible for maintaining data pipelines and migrations to include replace some legacy data warehousing system to use open source Trino. Brian is a published author in ACM and IEEE Geospatial Data Conferences. Welcome, Rachel and Brian, to our meetup group. Now it's all yours. Let us start with Rachel. Thanks, everyone, for joining.
You're very welcome. And Brian, I had no idea you were so impressive. Wow.
I'm not. It's all fake words, you just got to throw it on there. Let's see. Can you see my screen fine?
Yes, Brian. You can see.
Cool. All right.
Yes, we can.
All right, Rachel, do you want to give yourself a quick intro, and I'll do the intro, and then we'll get this thing started?
Yeah, I mean, that was a great intro. I mean, that was my bio. But my name is Rachel. How do you pronounce your surname? Pedreschi. And I run our community program here at Imply, which is focused around the project called Apache Druid. And I would like to see a raise of hands. I think we have, do we have the hand raising function? Like you can see under the reactions down at the bottom. Any people, I'd love to know how many people have heard of Druid, first off. Anybody? Anybody?
See if there's
all right. Oh, good one. Excellent. Anybody using it in production or trying it out? Okay. Ooh, got it. Oh, wow. Lots of hands. Excellent.
Okay, so for the
Okay, cool.
recording, how many people was that, Rachel?
A lot,
A
like
lot.
100 at
100.
least.
Wow,
At
more
least hundreds,
people,
yeah.
more hands than are here. Great.
See, when in person, I get to like see hands and like understand what people are looking like, get some feedback. So at least now I know. All right, I got some people who know what Druid is. Excellent.
Congrats for Series C, though.
Yes,
Congrats
congrats on
for
Series C,
Series C.
Rachel. Series C for Imply.
Oh,
Woohoo!
yes, right. Yeah, that whole thing that happened yesterday. Right. It was yesterday. It was a really long time ago. But
Rachel
yes.
hasn't had much sleep lately. Just forgive her.
All right, go on, Brian. You're up.
All right, so I'm up. Yeah. So yeah, I'm Brian Olson. I'm a developer advocate for Starburst, and we built Enterprise Trino. Yeah, and basically you heard a lot of what I do, just kind of in the community and doing talks like this, trying to basically pass messages back and forth with our larger community to like say maintainers and get people who need to be talking to each other talking. I do a lot of talking myself, as you can see. So without further ado, let's get on to the meat of the subject here. And the forward button didn't work, but the mouse click does. Rachel, why are we here?
Why are we here? Because the data writers were nice enough to invite us.
Well, that's one thing. Thank you so much about that. What's the other reason that we're here talking about this? Like, what are we actually going to bring to these wonderful people of data writers?
So actually, this topic came up over a drink, actually. And I was having a drink with a friend of mine who has recently left her job as an account executive at LinkedIn. And she took a job with a new company. I'm not going to say which one. And she was complaining about the reporting. She was like, I get, like, if I need data about my customers or my clients, like, I don't have access to it. And it takes like a day or a week to get these reports. And I'm thinking to myself, like, well, that sounds pretty standard. What was it like at LinkedIn? She goes, at LinkedIn, it was great. We just had this one interface and we were able to get whatever data we needed. It was super fresh. It like, I could ask it questions. And I'm like,
something from the movies.
Interesting. Look at that. And so I started asking around, and of course, in the industry, we've heard of Facebook has a system called Scuba, which provides their clients a very similar type of service. I talked to the team at Target, who has recently re-architected an entire open source technology stack to allow this level of data warehousing at Target as well. And I'm like, well, and I said, but so what are these guys using? And I start digging into the technologies, and I realized that the product that I work with, Druid, and my friend's product, Trino, are the types of technologies that underpin all these different types of and I don't know what else to call it. It's FANG style data warehousing. It's the ability to have, well, anyway, we'll get to it. Yeah. But the problem is, who has that type of budget except for those companies, and Imply now with our round C funding, of course.
Yeah.
But
making it rain.
Exactly. But most of our other, but most of my clients, most of the people that I work with day to day in the community aren't FANG level companies, but they still have the same ideas of what they need for their clients. So why we're here is to talk about what are the tools that are available that grew out of FANG, the FANG companies and these new data warehousing architectures, and why, what are they work, and where can you find out more? So how's that?
I think that was great. And so when it comes down to it, what are like the quintessential things when you think about the system that you're talking about? What is it that people actually want? These are like the kind of systems that you're seeing like on the movies that are like, they can quickly just search the database and like everything comes back in like 2 seconds, right? So like we got fast data, democratized data, which democratized data meaning like I can go to one location and not have to run to that database to get this part of the data, and I got to run to that part of the database to get that part of the data, and I have to know this particular language, like let's say Elasticsearch is like crazy, the domain specific language here, and I have to know SQL. Well, most people know SQL, right? So like I want to have like one language, one location where I can find all this stuff. That's definitely another kind of element of this like, mythical system, right? And so we want to actually also have this ability to run these queries as you think of them. So like, if I have to sit there and have this query thought of well beforehand so that it can run fast, AKA you cache everything, that's not even really innovative, right? You're basically just like writing everything you need down on a paper and pulling it back out whenever you need it. That's not like going through the, potentially, and this is the next bullet point, terabytes and petabytes or exabytes of data that you may have to scan over to actually like, rock through this whole entire database system that you have to actually get the first 3 bullet points. So let's talk a little bit about these two systems. As Rachel alluded to, like we are able to kind of realize this system with these two. So, Rachel, tell us a little bit about what Druid does to kind of make this a reality for people.
Okay, well, let's see. It's a distributed system. We'll talk about why a distributed system is important and where that came from in a little bit. It's fast. Back in the 90s, when I first started working in analytic databases, our tagline was performance is everything. I just surveyed the Druid community last week, and the #1 reason people pick Druid because it's fast, but also that it's interactive and ad hoc, meaning that the types of queries that you are asking it, you don't have to predefine. So different than a system like Cassandra, where you need to know what types of queries you're going to be using first. Druid allows you to do more of ad hoc interactive. It's an OLAP database, very specifically designed to table scan, to do aggregations, to do online analytical processing workloads. And it speaks SQL. So it does a lot of the things that these modern data warehouses need, right? It's probably the only answer, right?
This is kind of crazy though, because that's exactly how I describe Trino. Trino is also a distributed system that is very fast, and we pride ourselves on how you can run interactive queries, ad hoc, not having to have some cache special thing going on, and we also are doing analytics. So we are adhering to an ANSI SQL standard to actually run the language for Trino. So like I kind of don't understand why we are kind of being partners right now, and I feel like actually we are enemies.
Yeah, that's actually what this meetup is for. We're gonna have a Trino versus Druid cage fight.
I think so. So from here on in, Rachel and I are going to bear the gloves. I'm going to fly over to her house, and we are about to duke it out to see which one is the better system. No, we're not.
No, but we did have this conversation the first time we chatted, right? And you introduced me to the wonderful world of, tell us about this map. Yay.
Yeah. So Martin Kleppmann, I don't know if any of you have read his book, but he has these really cool little maps and how he breaks down this complex world of the database and just kind of data distributed systems and all these different pieces that kind of fall under a typical data engineering charter, right? And it's really confusing. And so one thing I really appreciated about his book are these kind of like, mental model visuals of how he mapped these out. And so, when we think about analytics, we're clearly in this split where on the left side here, we have this republic of transactional processing. So this is kind of your OLTP type databases where we originated from, I don't know, back in the 20s or the 30s or something like that, before computers existed. I think they would take like cards and just write little messages down and then take it by horse and buggy. And that was ETL, actually. That was old ETL in the 1920s and the 30s. Anyways, so, made it all the way back there. And now we kind of make our way to this kingdom of analytics on the right side here. And we have like this ETL highway that connects our transactional processing databases to our analytics and data warehousing side of the house. And so we're going to talk a little bit about like this kind of transition. If you see this little, and I just want to make sure it's really clear, this little road here is called the ETL highway. And we'll talk about what that means a little bit more for those that are maybe not aware. I think most people on this call will be aware of this transition, but it's always good to kind of talk about that just to get the context of our journey and how we then get into like the real nitty gritty of analytics and why this Trino land is sitting over here next to our little data lake. And then you have, you know, Druid over there on the other side of Column Storage Mountain. So let's dive into that a little bit. And actually, you know, I actually don't want to necessarily jump into this part because, you know, I wasn't really doing much with databases when, you know, back in the 20s and the 30s when Rachel was doing it. I was handed these Elder Scrolls whenever I was doing my master's at Purdue, and they said, here's how data warehousing works. But, you know, Rachel actually lived through data warehousing in its inception. So Rachel, could you bring us through that a little bit? I'd like to know from a wise sage like you.
Ha, ha, ha. And it wasn't like that far back, but very funny.
Okay.
Yes, but when we discussed, you know, when we wrote our first lines of code, I'm very glad that Zoom has the ability to make you look younger. So anyway, we're gonna hop in the Wayback Machine. So let's strap on. And actually, like, I've obviously Mr. Peabody, go back, because Sherman there is obviously Brian, especially when he wears his glasses. So we're going to hop in the Wayback Machine. We're gonna go back in time a little bit to understand where data warehousing architectures came from, so we can start making sense of how we got to where we are today with Trino on the data lake and Druid over in the mountains at the end of a river. All right, next. Whoops, we went back a little too far. So, all right, good. We're here in the world of RDMSs, like what, the 20s or the 30s that you talk about.
Yeah.
But the first the jazz age, right? And I like to use the example, and I'm sure a lot of people in this meeting know this, but at some point, us people of a certain age remember when grocery stores started giving us loyalty cards. And that seemed to be the moment where companies realized that they could take their transactional data that are sitting in Oracle or in Informix or a DB2 database, and they could start asking it questions that they didn't necessarily have to just use it for transaction processing. So we had one relational database, and it worked great. Okay, so next, we're gonna fast forward a little bit to the 90s, into the time of Spice Girls, and sometime around when Al Gore invented the internet. Thank you, Al, we appreciate that. And this is what data warehouses architectures turned into, because what people found was that their Oracle transactional systems weren't keeping, they didn't want to screw up those transactional systems, so they would take the data out and put it into a data warehouse. And this is where those tomes, those things like, you know, the data warehouse toolkit by, you know, Ralph Kimball, etc., came out that you've only, when you only read about. You know, talked about how to model databases for questions versus doing a third normal form. That was the traditional way of doing databases. So what's interesting here, though, is I just do want to point out is that ETL, even though it's a nice little calm looking box, for all of us that live this world, this was very, very, very complicated. And it would take sometimes 18 to 24 months to fully realize an enterprise data warehouse. And when I was actually doing this work back in the turn of the century, it took me a job interview to tell them what the star schema should look like. And it took me 10 months to integrate 33 different data sources in order to get the data warehouse where I wanted to be. So 18 to 24 months for a real enterprise isn't an exaggeration. So so that was great. So we had ETL, we had data warehouses, but there was always a need that the data warehouses became complicated. They were slow. People waited for the reports. So a new adjunct technology came up with called the OLAP database. Sometimes it would be called cubes. You would sometimes see these in like Cognos or Essbase, but this would be your more hot data. This would be the data that was more likely to be aggregated. And, you know, we had all these wonderful techniques in order to make the queries come back faster on this subset of data. We could also call it a data mart. All right, so we're going to fast forward again to the 2000s, when, you know, St. Jobs of Apple brought us mobile devices, and all of a sudden there was a lot more data. And this ETL thing became too complicated to do. There was click data, eventually mobile data. There was so much coming in that I remember even thinking to myself, like, there's no way that Facebook would ever be able to mine my data. They've got too much. Alas, they figured it out.
Yeah.
And they figured it out with, things like Hadoop and S3. And so you had this new concept of these data lakes. And again, it worked out really well. But so you, instead of ETLing the data into your data lake, you would sometimes have to ETL it out, or ELT, or schema on read versus schema on write. All right, so okay, where am I? Apologies. I have to catch up with Brian. He's going too fast for me.
My bad.
Okay, so, but the problem here is that Hadoop's mascot is not a jackrabbit. So it's not like, Commander Bun Bun here, the Trino mascot. It's slow. It's scalable, but everything is now slowed down again. And, there's nothing you can do about that. There's nothing that would make that better, right?
Well, like you just said, Rachel, there is something we can do about it. And you just talked about our jackrabbit. I mean, we were stuck in this little hive age. Let me take over here, because I think you're kind of, getting lost in the sauce of this, whole data lake thing. I know that you're so used to your real-time streams, and we'll get to that, but let me take over real fast and just talk a little bit about this whole, move from these vertically scaled data warehouses that we had before, and kind of this whole transition to this scaled out, horizontally scaled thing. So, we look at the history of where Trino came from. We look at the Web 2.0 as kind of, that was brought in by the St. Jobs. And so, we now have social media, we have phones and tablets, we have all these mediums to actually be online constantly. And the traditional vertically scaled solutions that we had from back in the day, that were just these giant OLAP systems that where one system is just, constantly scale it up, don't distribute the data that's complicated. It's gonna just, make things way too hard. Just throw more RAM at one system, really spend a lot of money on this thing and just make it work. But what's problematic about that, and one of the first things that we saw as data really started to increase, was that if you have this bus here to the left that's just vertically scaled up, there's one single engine that runs that, and if that breaks, then you're out two buses there on the left. Whereas and let's say you just take this metaphor to a crazy level. Let's say there is a bus that was stacked five high, and then that bus went out. That's five buses that you're out, and you have to wait till that bus gets fixed. Whereas buses on the left, all the buses are independent. One bus goes down, you're still fine. You just got to replace the one bus, and you have to then update how your programming works. But it's much more removable on commodity hardware, right? That was the big sell on Hadoop, is now you have this open source commodity hardware system that makes it scaling up much more affordable and possible for your systems. So great, we have Hadoop and we have MapReduce. Okay, we don't have any way to actually access your data, sorry. So we had to figure out a way to do that, right? And so Facebook actually came out with the perfect the Hive QL solution. Developers at Facebook created Hive, so the SQL and Hadoop thing that took these really complex MapReduce models and made this something that we can access through a SQL-esque type language. And now, instead of having to write these really complex MapReduce things, I think everybody kind of knows the story, right? We then now put Hive on top of it, and we say, great, we're back to square one with our data warehouses. We're good, right? But we're not good. We have all these wonderful things, but queries are still taking long. We have the same problem that we had almost at the beginning. We just now have a better model to like remove and replace computing and scale up a little bit more with this Web 2.0. So we haven't actually solved this slow problem yet. So, in 2012, Martin, Dane and David, Martin Traverso, Dane Sundstrom and David Phillips, I should say, they created Presto back at Facebook to solve the issues of the scale that they were going up into I think at the time, 300 petabyte data store in their data lake. And these guys really, kind of came at it from a whole new perspective of, okay, we need to make sure that this system works something similar like a system that they had worked on in a previous company together, where they used Netezza, was the commercial inspiration. Everything just worked. Like you plugged in Netezza. It was also a vertically scaled system, and had the hardware was all provided in one thing. But like you plugged it in, everything worked. And these guys went into great depths of an engineering rigor to verify that Presto had this kind of this capability to just plug into a system and all of a sudden just run. Obviously, it had to be fast. So to do this, they relied on a lot of Dane's particular distributed computing knowledge, and made a MPP architecture that kind of scaled at various different levels. At the internode level, we'll talk about that here in a second, and the intranode level in between, within a node on the thread level. So they really did a lot to kind of make sure that this system was not going to be having the same issues of kind of the legacy bloatware that was kind of happening with Hive and the whole Hadoop ecosystem, and really move over into something that was created from scratch and utilize every possible means of engineering, ingenuity to kind of make this system run super, super fast, right? Obviously, the correct results, that's another thing that, Hive didn't always give you expected things, right? Especially depending on which flavor of Hive you were running. If you were going on, the Hortonworks or the Cloudera or any other of these, sub flavors that they had something different, you wouldn't have like consistent results depending on, or maybe you were running the Apache version. And so sometimes things were a little bit wacky when it came to, depending on your configs, how things would actually perform or actually handle different scenarios, right? And then a big part as well, taking off the page out of the notebook with Hive having this HiveQL non-standard SQL language. They wanted to use ANSI SQL. They wanted to use JDBC, any kind of standard that they could get their hands on that was kind of some very good practice that they saw out in open source and other places in the wild. They wanted to apply these so that they can make Presto the best system. And I put this as my first bullet, but I'm kind of finishing with it. The biggest thing that they really pushed for from the beginning was that they wanted Presto to not just be this project that lived and died and did only the things that were needed in Facebook. They really wanted to kind of take on this esprit de corps of bringing on this open source and neutral governance model that would encompass taking in all these new use cases from people outside of Facebook and really making Presto into something that was useful for a larger community. So they really embodied this from the beginning, and luckily, Facebook obliged, and in 2012 they immediately were able to kind of take these prototypes, get a couple things running. I think they had it like Airbnb and a couple other companies working with them to get some trials out, and then they came out with the first version, I think, at the very end of 2012. So one interesting thing that happened while they were putting this together that wasn't really even an intention of Presto, there was a lot of things by them making it open source that they had, like, if we're talking about FANG companies here. Facebook had, Facebook and all the other FANG companies I think out there have such a good heavy amount of engineers that they typically kind of have their own versions of a lot of the open source systems, and they have their own like kind of customizations or Frankenstein version that they have internal that really meets the needs of that specific company, because they're a FANG company. That's the whole thing we're talking about here, that they can afford that. So with the Facebook specific kind of Hive code that they had to interface with, as well as the open source Hive that they needed to have this run alongside with, and there was also a couple internal Facebook systems that were very specific that needed to kind of interface with Presto as well. They started kind of seeing this thing that might be able to save them some time. So even before they released the very first open source code, they pulled in this layer that they hadn't initially planned called the SPI. So they basically, and I have these two empty things here. That's because Initially, I was thinking that there was an internal Cassandra and Postgres. I talked to Martine today. There's actually was just these kind of custom services that were happening within Facebook or the other ones. Hive was the only one that they connected to that was a Facebook specific of the open source. Just another little aside. But the point of it is that they had the SPI. This came in, and this is what we now know today for Presto, and we'll soon be talking about Trino. And these connectors essentially become this second big pillar of what we know and use Presto and Trino for today. And for those that don't know, this is a huge advantage. We'll talk about that here in a moment. So I'm coming from this Trino world, and I've just here been talking about Presto. So let me go through a little bit of a timeline just so everybody is kind of caught up on what's kind of happened in the last couple of years. So 2012, as I said, founders open source Presto. Right around late 2017, early 2018, there's all this kind of talk that Facebook wants to kind of take over. Essentially, Presto's doing super well at this point, and Facebook wants to have a little bit more, ability to kind of enforce their desires and needs for Facebook over, kind of the community at large. And again, this kind of goes against what the founders kind of set out, and they had their vision for Presto from the first place. So I think it was like late 2018, Facebook management group unilaterally kind of rewrote this like committership rule around Presto without anybody else being able to say anything, and how this thing was done. And what it basically did was gave automatic contribution capabilities to anybody who was on the Presto team at Facebook. So, this happens. I mean, the next day, Dane quits. I think the week after, Martine and David follow, and they go on and make the called Presto Software Foundation at the time. So this happens 2018. 2019, the official split happens between Presto SQL and Presto DB, and in middle of the year. Something kind of weird happened. They thought that basically this Presto thing was just going to be absorbed into Facebook, and that they were just going to continue on with the kind of community-driven open source version that is serving the rest of the community. But there was a little bit more traction that came back. Facebook kind of undid a couple things, and now we're ultimately sitting here with Presto DB, and at the time they were calling it Presto. We were calling Trino Presto SQL, and so. Going along, they end up donating Presto DB to the Linux Foundation, but still we're kind of seeing this overall primarily catering to Facebook, and Linux Foundation in 2020, basically late last year, forces Presto to actually move to a different name, and so we ended up choosing Trino. The bottom line I want to kind of pull from this slide too before we hop on to the next slide. When it comes down to it, the ethos and the idea that was brought along with Trino and the whole community following was that the companies don't really need to run open source projects. That people and the community that followed are the ones that actually run these things. So let's get into Trino now. We pulled the name Trino from the word neutrino. It's just a shortening because neutrino is too long, but we wanted to have this idea of this fast little space particle running through the air, just kind of like your data. So, and as those of you who maybe know Spaceballs, we like to call this the ludicrously fast query engine. So the maintainers now, Martine, Dane, and David, are still maintaining and contributing to Trino, and kind of steering the ship along with the other maintainers from LinkedIn as well as Line. And community and the project velocity has really just been outpacing Presto since the rebrand. And so one thing I want to be very clear about for those that are not as familiar with Presto or Trino is that they're query engines and not databases. So we don't store data, and I think I might be getting a little bit ahead of myself, but we handle these OLAP query workloads, and the way we hit this speed is that we use this MPP architecture. So here to the left on this this little chart here, this is a graph of the commits that have happened through the projects since the split back in 2019. So you can kind of get a sense for the velocity of each of the projects. You see kind of Trino picking up, kind of getting a little bit higher near the end, and you're seeing Presto kind of do a little bit of a dip there, just to the right. So it's kind of telling in terms of where things go. And I don't mean to bring this up to say a tit for tat, but it's, you know, we're kind of battling with the mind share and the understanding of Presto, like people hearing the name Presto and the familiarity. So I wanted to just kind of make that clear in terms of where the projects are right now. So I wanted to do this quick slide here to talk about that MPP architecture that we have been talking about. So there's this one distinction that's really kind of neat that they do, where they really focus on these two elements of internode as the kind of primary parallelization. But then you also, once you kind of get to this, you think of it almost like a hive where you're kind of partitioning and then dealing with buckets. So like at the partition level, you can actually use things like, you know, sending partitions out to each worker node. So you're still going to get little bits of each type of data sitting in there. And then further on down the line, you can actually use these really specific intranode thread level type of parallelization that actually give you a lot of this like in-memory fast CPU type speeds. So so that's just like one of the things I wanted to kind of make clear. Is like, this is one of those pieces that actually gives us that ludicrous fast speed. So in summary, you know, Trino is giving you this capability to connect to multiple set of data sources. So you can actually like connect to, let's say, at Mongo. Mongo, as you know, is kind of like one of those types of databases that their whole goal is to avoid doing joins. So they actually like specifically want you to denormalize your data and throw your data in there. And so like, in fact, you can actually, if you really needed to, you could perform a join with two tables that are sitting in Mongo and actually join it on itself, or you can join a table in Mongo and join that with your data in your data lake in Hive, because let's be honestly, you're never going to be able to get all the data that you need in one data store. So you can pull all these together. You can even see Druid in there, Elasticsearch. It's quite an amazing amount of possibilities here. You can even, if you really have the desire to, create your own connectors and basically make that own plugin. Let's say, in fact, in my old company, we actually plugged in a legacy service that we didn't want to necessarily, we had to keep it around. We didn't want to necessarily like, you know, update it or spend time messing with it. So we just used the traditional interface, and Trino is actually the way in which we pull data from that system. So a lot of opportunities come up here, and all of it, you know, you're going from these old Hive times where maybe you're running like 6 queries a day and only getting like, hour-long queries to, you know, maybe at the best 30-minute to 45-minute queries, right? And we're now getting back down to these speeds of like, you know, 1 minute, maybe just a couple minutes to finish your pull out all this data and join it across all these different systems. And, you know, for the most part, like that's what you need, right? That's all you really need. And so most data scientists will pretty much be happy with that type of service, you know, especially at that particular level. So, I mean, I don't see any.
Yeah, it's just not jiving with me. This is all great.
Well,
yes, you know, minutes to seconds. That's good, especially across all those different federated data sources, especially ones that don't do joins like that. I think that can handle a bulk of the traditional data warehousing use cases at ludicrously fast speeds.
Yeah, very fast.
A couple seconds.
Seconds. That's super fast, right?
Yeah, no. Well, okay. Well, it is fast. And I think we should probably define fast. And you probably could say this entire presentation is define fast. Like, what does fast mean? So what about the applications that are the now applications, though? The ones that need the data, you know, that's coming off of a watch or that's coming off of a mobile application, or where your users have a different set of expectations.
Well, wait, I thought you were talking about data warehouses, though, Rachel. Data warehouses is only for, you know, your internal company. Why are we worried about all this stuff?
No, it's not. So this is my big thing, is analytics and data warehousing has been stuck in enterprises as a cost center for years. Can you go to the next slide?
Yeah.
And it's time, and what we're seeing over and over again, especially on the Druid side, is that instead of these all being cost centers within an app or an organization, companies are starting to use their data to create applications that they can then sell or make available to their customers or to their partners. But the service expectations when you're selling your data or when it's part of the service that you're trying to offer are very, very different, especially, people who grew up with cell phones in their hands, or, people who used Facebook when they were in high school or junior high school, like some other people that might be on this call. Like they've grown up with that ability, and they don't want to wait seconds or minutes. They don't want to push a run button in terms of data that they're paying for. So what I wanted to talk about here, and if you go to the next slide, is that there's more and more people within these, not just in the organizations, that have become these citizen data scientists. But their expectations of how data needs to be presented to them have changed. So data warehousing needs have changed. So it's not just where's all the data? I need one place to access it, but I also need to create an application that's very, very interactive. Can you go to the next slide? So we could go back to this architecture, right? Where we have this OLAP style, like data mart that hangs off the data warehouse. But we have a lot more data now. So we need to kind of put together the two architectures. So what a lot of people have done, if you could go to the next slide, is created a serving layer. Oh, wait a second. That's the analytics architecture for big data. So next one, I think.
Yep, there we go.
There we go. Yeah. So people, what they've been trying to do is create a serving layer, or you might hear of it, Lambda-based architectures that sit on top of a data lake or connect directly off of Kafka or Kinesis or some other type of streaming infrastructure. And for a long time, they try to use, the fast NoSQL databases out there like Cassandra. But what really needed to happen is there needed to be a new technology that was able to read data directly from a Kafka stream, as well as being able to read it from a data lake. And so then we have our hot data access that an OLAP database used to provide us, but we now have it on a more of a data lake architecture. And I think, if I saw correctly, Druid is one of the connectors that Trino can use, right? So
yep, absolutely.
Yeah, so you now have the ability to have your hot data applications with interactive sort of UIs, but not sacrifice any of the query capabilities, because you can be able to put it together with Trino for federated queries. Next, please. I'm always surprised to see what my next slides are. So we're going to talk a little bit about Druid. And Druid powers analytic applications. So what you see here is the pivot interface that Imply provides. Imply, of course, is my company, so I am here thanks to them. But what's funny is that they wanted to create a database that could drive an application like that. So so the original authors that worked for a company called MetaMarkets that was eventually acquired by Snap said, right, we want to provide our users an analytic application for ad data, but there's no databases out there that are going to work correctly. And they looked at stuff that was available like Vertica, but Vertica didn't have any real-time capabilities, so it couldn't connect to a Kafka stream. They looked at time series databases. Time is a good component, but time series databases can't scale to the data volumes. And then they also looked at search systems like Elasticsearch and the Elk Stack. And those were great, especially this flexible schema portions, but there was no ability to do OLAP. And we're actually finding that a lot of people who migrate to Druid are coming from an Elasticsearch world where they were promised analytics in Elasticsearch and they can't do them. Elasticsearch is great for search. No two ways about it. Druid's not, but when you want to do more ad hoc analytic queries, you want to use something like Druid.
Yep.
So next, please.
I
know. Ooh. I sort of snuck that one in, didn't I?
Yeah, you did.
That was,
I thought, are we getting back to the cage match here?
I think so. Yeah. there's lies, damn lies, and benchmarks. And that was actually a benchmark done by the University of Minho in Portugal, looking at the difference between Druid and Presto, which of course is not Trino. Very different, right? Since that was what you just
Very
told me.
different.
Yeah. So how does this work under the hood now that I snuck that slide in? So Druid actually uses a microservice architecture. And because it was born in a post-cloud environment. So it is designed to work in a cloud environment where you don't have to have one particular node type in order to run your entire database. You can split up your processes based and then put them on machines that are more appropriate for the workload. And what happens is you have data, streaming data and batch data that's coming in from the right-hand side over here. And the indexer then takes that data and creates segments in deep storage. And we're going to go into a little bit more what these segment files look like in the next slide. But this is what the segments where all the magic happens. So once that segment gets created in deep storage, then based on rules, it's promoted up to the historicals for querying. And then the broker is able to decide, all right, do I need to take data directly out of the indexer, which might be our streaming data, or do I need to get data from my my historical stores? And then I can serve the queries. So, but what makes this fast? And in the next slide, we're going to look at what is the architecture of that segment file. So there's four main pieces of that segment file that are key in making Druid so fast. First off, there's compression. So different compression algorithms available, but also doing things like run length encoding, or taking all the data for a particular dimension and assigning it a single value, single integer value, which is much easier to scan and compresses much faster. Then we always will put a secondary index on top of that data. That will allow for fast scanning. The data is actually operated on it compressed, so we don't decompress it in order to do the scans or do the searches. It actually all happens within that compressed data. And last, that late materialization of the data, making that only the data that is required for the results of the query is going to get materialized. It's the only thing that's going to get uncompressed. So the engine and the data format are tightly integrated to make sure that the engine is working perfectly with the type of data that's in the segment files. All right, next. But I guess that leaves us, that leaves us to the question, like, can you have both?
And as we kind of alluded to before, I think we were already talking about, there is a Druid connector. So, one of our big fortes, is that we can actually pull in data from multiple queries. And this is going back to that SPI that was, kind of unknowingly put in there as the kind of one of the central pillars of why Trino is so successful these days. So you have, federated data sources. This again can be Mongo. This can be Elasticsearch, like that. Especially if you're migrating between systems like that. You could let's say somebody's on Elasticsearch and they want to move to Druid. Like Trino can operate, pull data from both of them while you're doing that migration, and actually even do the migration as well for you by moving that data around by doing like a pull from one database and move it into another database, or by doing like a CTAS type query or create table as. So, you have all this capability now for what, Trino was originally created for, pulling data from your data lake and federating it with other data sources, but you can also federate it with your real-time data store. Now, what's interesting, a kind of extra layer that you get on top of that is if you are wanting batch, so Trino doesn't do anything special where it all of a sudden kind of magically turns into some real-time system. Trino is actually still doing batch, pulling data from Druid. It's just doing it with whatever data is available at that exact time. And based on how the connector pulls a subset of data from Druid, which actually relies on Druid itself versus going, like, let's say, directly scanning one of those historical nodes or anything. It goes through the broker itself to actually pull that data. So Trino is doing nothing magical, like just directly trying to reach into the honeypot of what Druid has for it, right? This way, Druid still has its magic powers, and Trino is not, again, like we kind of alluded to before, not really getting that extra speed up, that sub-second latency that you're looking for with Druid, but it does give you this view across this at least second to a couple seconds type view where you can pull from all of these data sources and all of a sudden not have to move any data around to get it in one spot. No, you can actually pull it in ad hoc as you query the data, as you think of that query, and pull it from Druid, pull it from Mongo, pull it from any other data source that you have, maybe an operational database like MySQL, as well as your data lake, and federate those queries, basically run joins across them, union them, whatever needs to happen. Trino can do that. And then you could also then say, well, no, but I still want to have that capability to do runtime. Well, that's fine. You can still directly talk to Druid. We both speak in SQL, a slightly different dialect, but for the most part, it's roughly the same language. And so, you know, for that, you know, yes, I think the answer I would say hands down is you can absolutely have it all. And I think, you know, we've seen it happen before, right? So we'll talk about that in a minute, but let's go kind of back to this original slide for the cage match, right? If you look at the stuff that we had kind of mentioned before with Druid and Trino, we kind of had this weird SQL query thing that was kind of vague. And that's kind of how we call it like that, because when you are somebody looking to say, okay, I need to scratch this particular itch in my company, I need to basically figure out what project or what technology I'm going to use to fulfill that, to basically scratch that itch or fulfill that need. So you start looking around, and maybe unless you're absolutely, you know, been in this space for the years leading up to it, and you've been keeping track of all the technologies coming out, which I don't think everybody can, you know, this might be your first time looking around at all this stuff. And I think the thing that Rachel and I are trying to point out here is like a lot of the words are the same. And a lot of the words, you know, this is just the English or any language is, you know, they're ambiguous. They're very vague. When we say fast, what do we mean? And so we're trying to kind of break that down, at least when it comes to real-time system versus other systems. So let's scratch out that SQL query thing, and let's actually talk about what they are. They still both do SQL, but when we actually get into these two things, it's these really nitty-gritty small things that make the difference of the entire architecture of an entire system. So you have databases on the left side, and you have a query engine on the right side. So, you know, Trino, the big clue there is we don't actually store data. We rely on Druid, we rely on Mongo, we rely on MySQL, we rely on all these other databases to actually store the data. And we do not want to mess with storage one bit. We want to pull all these data. You do the storage, we'll basically pull all of the data in, try to answer the query with as minimal work on Trino as possible, and let every database do all their work. And then we basically take that kind of subset that's only going to answer the query and join it together, do what needs to be done, and return it to the user, right? So we're the query engine. The database is there doing all the hard work of how do we index this? How do we actually make this work in the storage later so that we can pull this out in sub-second latency like Druid does? The other thing is, Druid is handling this streaming use case and getting you answers on this streaming data in sub-second latency. So like Trino, on the other hand, is more focused on, you know, trying to make a much more generic case of talking to everybody and trying to have a generic case whenever we're talking to a data lake. We are storing in a format like ORC that isn't going to be some fancy index that has all of this optimization on the storage layer. We're basically just relying on the fact that, you know, it's going to work. It's going to be really fast as we can possibly get it, but generic enough so that we can do something where we are talking to a whole bunch of different databases and joining that data real time. Not real time, sorry, ad hoc, really fast. Okay, anyways, you know, you get what I mean. So Rachel, tell us about a couple times where we've seen this in practice, specifically with Trino and Druid, and or maybe even some variation of Presto.
Yeah. So one, Brian and I did a meetup with the guys at Netflix. One of the, you know, one of the pioneers of this architecture. So if you missed that, go check it out. I think there's a recording of it somewhere. It's from the either meetup groups will have that particular recording, but it's really, really interesting on their actual implementation and what projects they're using it with. We have a few other names up on the screen. Not all of them are FANG, but what we are starting to see is that the early adopters have paved the way for the early majority to start using these technologies within their system. So most of the clients that are in production with both are going to be, as I said, early majority, or they're going to be cloud native or cloud pioneer style organizations. But for the most part, you'll see this actually. Did I cut out? Sorry, that's probably me.
Yeah. Could have been me too.
Yeah, anyway, long story short, you're going to see this architecture in the Valley in a few different places, and even outside the Valley to some of the cloud native companies.
So we want to talk a little bit about community and how this kind of affects this trend towards paving the way, but also kind of making it available, and kind of why we think that open source, or at least what makes good open source so valuable. So, a lot of people are talking about open source, and everybody kind of has their versions of free. But I would say the overall, kind of goals of open source is that you have some version of free, depending on how capitalist or how maybe socialist or whatever, or democratic socialists that you are, then you are kind of falling on some spectrum of what your definition of free may be. But the idea is that open source is open, right? You have some ability to reuse it, and you have the ability to modify it and maybe make your own version and all these different things, and that's great. That other big piece is like, you want the actual thing to be useful. And I say this because this is super important in open source, alluding back to kind of why Martine, Dane, and David made Presto open source from the beginning, right? Is to make a system that's useful, you need to pull in use cases outside of just your narrow scope of one company. Even if you're Facebook, you're not going to be able to handle everybody, you're not going to cover everybody's use case, because you're a giant megacorp. You're not going to have the same use cases as a company with 5 engineers and a brand new startup. And so, this idea of being useful needs to expand the definition to not just giant FANG companies, right? Needs to expand to mid-sized companies, as well as brand new startups, or just your garage companies, right? So and I think the final one that we hope to see in kind of open source software is that it's long lasting. A lot of us, myself included, are open source contributors, and I don't think any of us really want to dedicate our time to something if we don't believe it's going to be something that helps people and is going to stand the test of time. So I think that in order for these projects to be successful, a lot of times, and you see this kind of early graph. By the way, this is a modification of a bias and variance graph. So this isn't the perfect graph, but this is the one that came to my head. So I literally just changed the axes and the lines labels. But anyways, so your left, your kind of blue line here is the early adopters FANG kind of starting up really high in adoption for the new community members adopting this, and it kind of goes down, right? And then your late adopters, again, most tech companies are going to really start to pick up as the project matures, as kind of the FANG companies have established, I think, the bulk majority of use cases, and especially their like supreme crazy use cases. They kind of go out and they start doing talks about it, get people to know about it. That's another thing, kind of awareness. But then as the project matures, you start to focus instead of on things like performance and how do we actually make this incredibly insane, amazing database or data store or whatever, or query engine. You start to focus more on things like how good is our documentation? How do newcomers that come onto the project, how quickly can they go from like hearing about the project to actually like getting a proof of concept up and running to show to their boss? And this, I think, is the piece that really makes the difference between that long long lasting, that particular last bullet point, and the useful one. Because if you don't open that up, then, you know, to other people, that if that red line doesn't start to go up, then your project, your open source project, is going to eventually go dormant. It's going to start to taper off. You'll see it, and you'll eventually see that project just disintegrate when the next new cool open source project comes along. So the only way to keep an open source project long lasting, you need to keep these late adopters appeased, and you need to really consider what are the use cases that they're really focused on. So this is how, you know, you get this FANG level capabilities at these companies, and this is fantastic when we see this. So this is where, you know, I think if I were to guess where Druid and Trino are at in this journey, you know, right, you see the inflection point there. If you go just, you know, I would say a little bit to the right, we're probably right about at that point where we've already made that switch to FANG adopters have definitely already, you know, come on board and use Trino and Druid, and we're very ubiquitous in the valley, right? But we really want to get out there to basically mid-level kind of companies that you know, have maybe even the staff there, but you know, they still have to be very careful and choosy about how they spend their engineering time, because they're trying to keep customers kind of happy while they're trying to innovate their new products, right? And so there's a lot of difficulties there. And then your new startups who practically have like 2 or 3 people running the entire data set, the entire data team, and they might even be also doing the front end as well. So you know, bottom line, as the project matures, we have to start bringing in all these new use cases, and you know, that's where you start to give this FANG capabilities that we're talking about here to, you know, every other tech company that isn't, you know, constantly talked about. And so so I think that was kind of the big thing. Rachel, do you want to kind of say your piece on this, or Rachel? Are you there, Rachel?
Yeah, I'm here. No, the cat was meowing, so I put myself on mute, and then I was talking on mute. The thing. Anyway, so yeah, community. What Brian said, good. We like community. And actually, you can go to the next slide. That's fine. We did actually have a question, like really early on, about, you know, Druid versus Pinot, which is a really great question. So Druid versus Pinot, and actually we'll even add ClickHouse in there, because you talked a little bit about Presto. I will say that, you know, ClickHouse, Pinot, and Druid fit the same use case. So everything that I said about Druid here, you could probably fit Pinot in or ClickHouse. And, you know, specifically, Trino is being used with Pinot at Uber, for example, for the same type of use cases, and at LinkedIn for the same type of use cases. So it's not, you know, this is these are community projects, and they all have, you know, a very strong, you know, open source communities behind them. What are the differences? The differences come down to various features. And, you know, if you want joins, Druid and ClickHouse have better support for joins. If you want updates, Pinot has better support for updates. If you want exactly one semantics with Kafka ingestion, Druid has better Kafka ingestion. You know, I'm of course going to plug the Druid community because that's where I live. And so we'd love for people to get involved. We have the GitHub project, the Apache Druid project on GitHub. And then the next slide, we have some other places that you can get involved. You can click next. Yep. So Druid Forum is our discourse forum. There's a Slack channel in the ASF Slack workspace. Go to the Druid website, lots of good information there. Email community@imply.io if you want some Druid swag. Since I couldn't give out t-shirts and stickers here, I will happily mail them to you. And send you over whatever swag you want. We'd love to hear your stories. If you are using Druid, you know, please contact us and we'll put your name on the Powered By page or do a spotlight post. We love hearing how people are using Druid in the wild. And if you're using Druid and Trino in the wild, oh my gosh,
definitely let us know. Yeah, we'll cry. Okay, so I'll do my little pitch on community here for ours. First thing, the date that's up there on Trino Summit literally just changed in the last 2 days. We found out that September 15th is on Yom Kippur, and we did not want to do that to our anybody who celebrates Yom Kippur, right? So so we have moved that now to October 13th. We have taken down the register page. If you go to that page right now, you can do a save the date, but it's also saving the wrong date. So please stand by on that. If you want to kind of keep your, basically hear about when we're gonna do that, reach out to me directly here or join our Slack channel. And we're gonna be broadcasting all that information when it comes out. I think it'll be probably early next week, if I were to guess. And then we will be updating the dates and everything. So Trino Summit's going to be awesome. It's going to be a hybrid event. We're going to be talking about anything from data lake type topics. A lot of stuff going on with Iceberg right now. I don't know if anybody knows Iceberg here, but it's kind of the table format that is replacing Hive table format from eons ago, right? The slowness and so yeah, so a lot of cool stuff that we'll be talking about there. Netflix will be there. Rachel will be there as well. And then so join us on Slack if you want to just start checking out what's going on in the community, and we will broadcast the update on the Trino Summit at that time. Other thing, Trino Community Broadcast is a broadcast where that kind of streams out into both a Twitch stream plus LinkedIn stream plus YouTube stream, and ultimately stays on YouTube forever. And then we also put it into a podcast, which is why I call it a broadcast, because it catches all that. So go to Trino.io/broadcast. That's where you can check those out. I had Rachel on a couple episodes ago. I also had a lot of the people from community or the creator of Iceberg. Occasionally Martine, Dan, and David join us on there. We have Trino virtual meetups that are kind of split into three kind of segments or regions. So based on what region you're in, definitely join one of those. And if you want to contribute to the project, go to Trino.io/development to learn more how to do that. Or you can even go to our GitHub. Check out our blogs or contribute to blogs if you are using Trino, and especially if you're using Trino plus Druid, and write a blog about it. And then, or if you are interested in doing docs, please put that on as well. So thank you so much, everybody, for coming. These are how you can reach out to us directly on the Twitters if you're there. And I will, guess, open it up for questions. Anybody has a question they'd like to ask?
And you definitely won the over/under.
So this is different over under, right? So we use Dremio a lot as a data virtualization tool. So what is the difference between Dremio and Druid and Trino? So what makes it as a virtualization tool in terms of?
So
Druid and Trino. It is Dremio. Okay, that's good. Go ahead.
So we're saying Druid. You meant Druid and Trino, right? The difference between these two?
Dremio.
Dremio.
Oh,
He's
sorry,
saying,
Dremio.
Yeah.
So okay, great. So Dremio is definitely in the same space, the same way that we were talking about. And actually, I meant to get back to our thank you slide. The Dremio is in the same exact space as Trino. So what Dremio is based on the what's it called? The one that's based on the Dremel
Drill?
paper. I'm really having a
Drill?
blank. What was it?
Drill?
Drill. Thank you. My gosh, I was like, I remembered the paper, but I couldn't remember the actual technology. So yeah, Dremio is based on Drill, and they also use Airflow. I'm not a Dremio expert by any means, but I know that when they kind of store things in memory, they rely on a lot of kind of like existing projects to do so. And I'd say one of the biggest things that I didn't get into too much specifics, but how we store kind of data in flight, we do a lot of customization in terms of how we store that data in flight. Every type that is represented, SQL type that's represented in Trino has a very custom representation and is constantly getting changed and updated on the fly for every single query. In particular, we write particular bytecode that will optimize based on the shape and the schema of the query. So so these types of small little twitches, like small little tweaks, I mean, increase that customizability, or that super, I guess, kind of like what a lot of people consider overkill. This is kind of the difference between the two. And in practice, what we typically see is that Dremio, if you go and sign up for Dremio on AWS right now, you'll notice that like they have the storage. I think the default thing is you pay for 50 gigs of storage, so it's an S3 storage, and then you'll pay for 50 gigs of SSD. That's for your caching. So Dremio, when you start to scale up, there tends to be issues, and again, this is all based off benchmarks that we run internally to Starburst. We don't publicize those, but we basically, if we're talking to somebody who's considering between the two, we can kind of offer that out. So that's just something that if you're in the conversations with Starburst or whoever and trying to think about the difference between the two, or if you come to me directly in the community, I can provide those to you. But basically, we see as it scales up to these kind of more, I would say, I think it was like when we start to see the higher gig to petabyte, we start to see a bit of a shift in slowness that comes from the Dremio side. So there is a performance implication that we will claim, and of course that's coming. I have this whole blog written about benchmarks. Like this is coming from me talking to you on behalf of Starburst, and talking about this other technology that's in our space. So when it comes down to it, like I'm gonna, I believe I'm here because I believe that Trino is the faster technology, and so in that case I have a bias, right? My best suggestion is to go out there and try both out yourself for your particular use case. Because one thing I will say that Dremio does have is a much better UI, a much better way to interact with the data than what Trino provides out of the box. And so if it's, to me, usually between those two, it becomes a kind of UI and kind of I guess interaction and documentation thing, which we are doing a lot to fix and make up for that, versus a lean performance and capabilities out of the box. So that's my general overtaking, and I just when I get asked these questions, I always have this little thing on the back of my head, but why should you believe me? So that's I'm gonna leave it at that. There are a lot of things that if you do want that, go on the Trino Slack and ask me for the benchmarks, and I can give those to you. But I think the best way in terms of convincing yourself is to kind of see if you can run even a small, on the order of some gigs, and try to if you can get to like at least 100 gigs, start comparing some of the performance there with the cache turned off. There's this kind of claim that they have out there, is a very hilarious marketing claim where they say they're 3,000 times faster than Presto. And so what they did for that is they just turned on the cache and I think most people can kind of, even just seeing that figure, you kind of know what they did for the benchmark, right? You just turn on the cache for your system, and then you turn off cache for everything else. So that's kind of the overview of how I typically answer the Dremio versus Trino type question. But yeah, they definitely are in the same space. They solve a lot of the same type of issues, and so I definitely would encourage you to try both, and join both communities as well, and kind of get the feel for what's going to be best for your particular solution.
Remember, Brian, lies, damn lies, and benchmarks.
Yep. Yeah. I have a whole I can share with everybody on this Zoom link if anybody wants to read my talk about benchmarks. I have this whole thing about benchmarking, and it's I did a Justin Bieber cover where I basically sing about this silly practice of benchmarking. So I can share that after we're done with the recording. In fact, I'll stop sharing and I'll share it right now with everybody.
Yeah, that'll be definitely useful, and it's going to be fun, I assume. So do you have marketplace offering or SaaS offering, or
do you want to go first, Rachel, and then I'll go?
Well, maybe she's asking if Trino does.
Oh, are you asking about Trino?
both? Let's go.
Yeah, go ahead first, Rachel. I'm
Cool.
gonna look for this link real fast.
Yeah, so Imply does offer a not a SaaS-based version of Druid, but a hosted service called Imply Cloud. So it would run in your VPC, and we would, our robots manage it for you, because it makes Druid a lot easier to use. That is available in the Amazon marketplace. So I will send out that link. I'll find it.
Okay, and I am about to paste in the slug for my what is benchmarking and why is it bad? And feel free to check out the Justin Bieber cover if any of you are Justin Bieber fans. Okay, so mine is Starburst just came out with a SaaS offering. Traditionally, before we offered Starburst Enterprise as kind of a Kubernetes offering, as well as I think we had there's a template service that's escaping me, but their templatized service on AWS, whatever it's called. There's always too many. So that was our original one, and then recently we just went GA with our product called Starburst Galaxy. So this is the this was, I think, just late May. So I mean, fresh off the presses, we have a SaaS offering now that you just click the buttons, deploy it, and basically all you do is specify, your connectors so that, this is where this data lives, this is where that data lives, and boom, like you have a query editor, you have all these kind of like this thing called Starburst Insights built in that kind of gives you insights on how long these queries have run, who's running them, and all these other cool, nifty little tools that we're packing in there. And so we also just announced this other cool thing called Starburst Stargate. So if you have, say, Starburst or Trino running in AWS, and you have another Starburst cluster running in, let's say, Google, you can actually federate queries across, your data sources sitting in AWS, as well as your data sources sitting in Google Cloud. So this kind of gives you that whole another level of flexibility if you want to like literally just run all your queries from one cloud, but actually query data residing in, let's say, Google or Azure or all these other ones. So it's a fantastic new tool. And if need be, I can send any links after the show if that makes sense. So yeah, so we do have a SaaS offering. Really excited about it.
Awesome. Thank you, Brian. Thank you, Rachel. I would let others to ask question, and then I have one more question, but if anybody else has questions. Okay, I think I can go. So how do you address the data sovereignty issues? You have mentioned somewhere that it is multi-tenant, right? So maintaining data across the countries, right? How do you address that? We can spin up clusters, or how it works?
So is this for Druid or Trino? Would you do both again?
Yeah.
Okay, take it, Rick. You go first, I'll go next.
Oh, so you're asking about how to do a multi-tenant implementation with Druid?
Right. Specifically with respect to data sovereignty, wherein data from one country should not be accessed by data from different countries, right? I understand the SaaS offering could have something, but in general, if I want to host this whole package in my account, cloud account, AWS account, say for example. So
yeah, there's a few different ways you can do multi-tenancy in Druid. They're fairly straightforward. You can have separate clusters that would work probably the cleanest in terms of in different regions, have a different cluster in a different region. The next cleanest would be have a different data source for each country or each set of data that you need to have. So you could duplicate it that way. And the last is that what we sometimes have people do is we do have them commingle data, and then based on a tenant ID, filter out that data at display time. So it would go into your where clause in your UI or into your query reporting platform. But then also there is a full security framework within Druid and Imply that would allow you to define roles and users and permissions. There is not at this point, though, cell level security out of the box. You would have to implement some type of cell level security yourself. So that's what I'm saying. Probably the best way is either to separate data sources, which means separate tables in Druid to use relational database vernacular, or a separate cluster.
A lot of questions are posted in the chat. I will go over one by one after Ryan's answer about multi-tenancy.
Yeah, so it all depends on, so Trino gets around it in a lot of ways because we're not a database, right? So it depends on the data sovereignty laws. And for the most part, in practice, sovereignty laws kind of specify that data in flight is fine as long as you're not actually taking that data and storing it on a persistent storage and with intent to let it reside there for any like long given time. So the way that we usually get around it then is if you're able to run a Trino cluster, and let's say you do run it on top of, let's say, across state boundaries, you will as long as you verify that it's in flight and that you make sure you never actually write it to any type of like other data store, then and there are actually rules that you can actually set within Trino to even disable that and go that far if there's like auditing requirements. And so so yeah, basically that is the capability, and as long as you don't end up like writing it to any store, that's perfectly fair game, and that's also how we get around it in the SaaS offering too. You're able to do now the Stargate kind of thing where, let's say GCP is located in a state where there's data sovereignty. You would just have to kind of basically make a rule for any data coming across that line that says that like you're not able to do a write query when you're querying from this data source. So essentially it has to always be read. So if I try to do a create table as or insert from, then those will like just shut down if my from include one of these data sources. So that's how we typically address it, and we get it a lot easier because we don't actually store data. So in Rachel's case, you have to have two separate clusters. In our case, you can get away with the whole, the data's in flight. It's just memory for like a couple, sometimes a couple seconds. I know not sub-seconds, but we can't have it all, can we? But we can. So.
Okay, thank you both. And there is a question from Gaurav, right? It would be great if we can have Druid versus Pinot comparison. As in, when and why to use what?
Right, I actually addressed that question during the presentation, but for the most part, Druid, Pinot, and ClickHouse all solve the same for the same use cases. Their architectures are very similar. The differences are going to be in sort of the implementation details, and I would say, Druid supports joins. Pinot does not. Pinot has better support for updates. Druid has better support for exactly what semantics within Kafka. Also, Druid will aggregate data on ingest, where Pinot will only do it at query time, while you have the option for both in Druid. I mean, I don't have any more sort of specifics. Every benchmark that we've run against Pinot, we've done well, they've done well in certain queries. It's all very neck to neck, to be very honest. I would say that at this point, Druid is a more mature project, and it has a Series C funded company behind it to really, I have an entire organization dedicated to making Apache Druid a better project, more resources. So there's just more resources right now available for Apache Druid.
Okay, thank you, Rachel. And the next question is about Trino. Okay, Sainath Pala asks a question about, are there any connectors available for Aurora PostgreSDB?
PostgreSDB?
Yes, Aurora Postgres streaming.
Aurora. Oh,
Yes, from the
I-
AWS. Yeah.
yeah. Okay. So is there JDBC is like not compliant with the regular Postgres?
So it's an additional layer on the Postgres. So it's something like an Aurora Postgres. So, but I mean, I was just curious to know, but yeah, probably it's something similar to the Postgres
Yeah.
as well. Yeah.
We have, so I imagine if it's anything the same as like the regular Postgres, you might be able to get like by with it. There's a pretty generic like API that JDBC API will expose. And so we have actually almost like a very like between MySQL and Postgres, we have a very similar type of what is it called? A type of implementation. And that goes the same, like anytime we make an update to MySQL, we'll try to make the same update to Postgres and any other one that we're going just directly through the JDBC, unless it's like a more special like underlying system. But if it's one of your more traditional database systems, there's not too much that you have to do on the connector side to actually make that work. So I would imagine that, and I can't speak, I've never used Aurora and I haven't dealt with anybody who's used specifically Aurora Postgres, but my intuition, my guess is that if you use the Postgres connector, the regular Postgres connector, it's going to be like pretty much compliant, and you would basically just want to run through whatever use cases that you have in mind, like in anything that you use typically, and just see if that returns any issues. And then at that point, you would just report that, hey, I'm running this through Aurora, and this is some issue that I'm getting. And so at that point, we may recruit you to implement a new connector. So,
So yeah, thanks for that. And I had an additional question on that, Trino. So like we're trying out like Druid recently in our company, and then so we had the same question of how to run on the federated queries or on how to do the analytics part, because Druid cannot handle some of them. So, and then we have decided to go with Aurora Postgres, but looking at the Trino, so we want to try out Trino in our system once. So do you have any trial options for Trino in general, like, because the Druid currently runs on Dockers. So I see there's a Druid on like a service provided by Imply as well, but it's already set up. But when it comes to Trino, we haven't done anything. So we want to check out if there's anything that you provide on trial, so we can check out how it works.
Yeah, if you, so I will say, for the interest of brevity of time for other questions, do you mind reaching out to, like, joining our
definitely
Slack, and then reach out to me? I have a whole bunch of stuff I can give to you, and trust me, I will talk to you. However many questions you have, we can take it on Trino. I'm always online there. So
definitely,
Rachel will tell you, she bugs me in the middle of the night sometimes, and I'm like, I'm in the middle of putting my kid to sleep. What are you talking about, Rachel? But yeah, I'm online a lot. So ask me anything. So
sure. Thanks.
There's one more question. Thank you, Brian. So there is one more question. Purbasha. His question is, any plans for a Trino connector for Snowflake?
I saw that one come in, so I'm prepared. So first, I'm going to send you the Starburst answer. Yes, Starburst has a proprietary connector right now that we can connect to Snowflake. So that is, for the enterprise and Galaxy versions right now. And so unfortunately, that's not on the open source side yet. But let me put in the next pull request. There is a longstanding pull request that's still going through some revisions right now. So, and that one's totally contributed. It's very totally separate from the one that we created at Starburst. So, so that one has been making its rounds, and so keep track of that pull request. And I think, probably, I don't know, we could say in maybe the next couple months to a year, you might see that one come out in the open source. And then usually what happens in that case, when Starburst has one that they've created, and then open source goes and creates one, they'll usually kind of try to take the good from that in the Starburst side, and then we'll end up contributing out a couple of our proprietary pieces back to the open source at that point. So yeah, so that we'll have to see how that plays out. It's one of those kind of song and dances that happen between open core projects. But yeah, keep track of both of those. And if you are, already convinced to go to enterprise, then yes, that the answer is yes today. You can have Snowflake connect to that. And what's fantastic there is that, if you want to, Snowflake has this capability to kind of have external S3 stuff, but it's ridiculously slow. It takes away the whole point of using Snowflake. So this is actually like by far, like I don't even like the benchmark is ridiculously like off on how much faster it is to deal with the external S3 or data lake versus federating it through Trino. So and then plus you also get the added benefit of federating it with other queries at that point. So yeah, definitely give that a shot. And if you want to see it in the open source side, check out that pull request. I don't know, the guy kind of quit talking or responding for a while, so maybe if you're interested enough, you might be able to pick that up as well. We are always really happy to have people contributing to Trino as well.
Thanks, Brian. Thank you for that answer.
Yeah, great.
Any more questions? Okay.
Fantastic.
I think, yeah, let's, end note, right? First of all, thank you, Rachel and Brian, for the wonderful session. It is fun-filled, interactive, educational, and we learned a lot about both the tools, Dremio as well as Trino. And hope everyone had the same feeling. And so we will be posting this slides, videos in our GitHub repo. And any questions or feedbacks, you can also post it in Data Writers channel. And thank you, Rachel, once again, and Brian, for the excellent presentation. And thanks for all those who joined the session and learned about the tools. Thank you, everyone, and have a wonderful rest of the day.
Thanks, everyone. Thanks for having us.
Thank you. Thank you very much for hosting us.